All right, friends, welcome to 1.5 Notes Completion, Measuring and Constructing Angles. We'll get the compass ready today. So today we're all about angles, my friends. Naming the angles is pretty simple, and you learned it in the past. And an angle, first off, what is it? It's a set of points consisting of two different rays that have the same endpoint. That endpoint, of course, is called the vertex, and the rays are actually the sides of the angle. So when we name it, a couple different ways. You can simply call it angle A if it's the only angle at that point. If I have multiple angles happening at a point, then you can't just use one letter, but in this particular diagram, you could just call it angle A. 3 letters is the safest way, with A being the middle letter, so BAC or CAB, or if they have it numbered, you can just call it angle 1. The interior, the points between the rays, exterior, points outside. Protractor, we will do a little bit of protractor usage this year, and we'll talk more about reading it at that point, but for the most part, your inner numbers measure angle in standard form, your outer numbers measure the angle if it's the other way. All right, types of angles, you are familiar with these: acute, right obtuse, and straight. So let's get into the good stuff. Okay, in section 1, 2, we had the segment addition postulate. In this section, you actually have the angle addition postulate, which just says you can add up 2 little angles to equal a larger angle when the angles share a ray, like what is pictured here. All right. And official definition of P is in the interior of R and T, of our ST, I should say. Then you can apply the angle addition postulate. Example 4, pretty good illustration of this. So they tell us that LKN, the entire angle, is 145 degrees. Then you can set an equation up using the angle addition postulate that says 2x plus 10 plus 4x minus 3 equals 145. Combine like terms. Subtract 7. Divide by 6. X is 23. And then it wants us to plug them back in. So let's see, 2 23s is 46 plus 10 is 56 on this angle. 4 23s is 92 minus 3, 89. And together, make sure you get 145 when you add them together. All right, pause the video here, try the monitor progress. We'll pick it back up. All right, so hopefully you got X to be 13 when you tried this one, and then plug it back in 125 and 55. When you see a straight angle, that is telling you 180, 180, 180, 180. All right. Now, bisector. We talked about bisectors for segments. You can also bisect angles. So in this case, they tell us that BD, ray BD, is bisecting the big angle ABC. So therefore, we know that this little angle and this little angle, ABD, would have to be congruent to angle DBC. So we can plug in 6x plus 14, set it equal to 3x plus 29. Subtract 3 x's on both sides, subtract 14 on both sides, divide by 3, x is 5, and it wants to know what ABD is, so plug it back in. So we have 6 times 5 is 30, plus 14 is 44. That angle, you could double check. Make sure you get 44 on this side also, since they're equal, and indeed you would. All right, now on to the construction part. So we need our compass. Okay, first off, constructing a segment, which is what we were going to do a couple sections ago. Pretty easy to construct a segment. All you have to do is open your compass setting, all right, to however long the segment is, in this case CD. Draw a ray that's longer than that. And then bring down your compass to the new point, and you can guarantee that this length is the same as this length. So a compass is a more precise way to measure than a ruler, because sometimes you have to go in between the dashes of a ruler. All right, now congruent angles. Much trickier to construct an angle congruent to a different angle. So we'll follow these steps in our notes. So first off, let's just draw an angle. Use your straight edge to construct an angle. Now when we duplicate this angle or copy this angle, start out with a ray longer than what you need. All right. Take your compass, move it in to the somewhere it doesn't have to, no set space. And the interior of the angle that you're trying to copy, draw an arc like so. Now keep the compass setting the same. Come over here to where your new ray is and draw an arc suspended into space. Now here's the tricky part. Go to your old angle and measure the distance or the width of the opening at that point. So be precise with it. All right. Once you have that opening measured, then you want to come over here. I have to flip my compass. Hold on a second. And you measure that same distance apart, because it's like you came out a certain length from the beginning of the ray along this line, and you said, okay, well, this far out, the angle is opened this width. So now we want to do that same measurement out and see how far its opening is from there. And once you have that point, then you take your straight edge and you use your straight edge to connect the vertex with where your arc your two arcs intersected. And that is how you duplicate an angle. These angles would be congruent. We call this angle A, this angle D. Then the congruent symbol can be applied here and here. And also you could say angle A is congruent to angle D. That is an angle symbol, not a C. All right, and then bisecting angles. The final thing today, this is easier, a little simpler to see too. So somewhere over here, let's see. Let's put an angle here. Now, remember what bisect means? We want to cut this angle in half. So take your compass, and your compass setting doesn't matter now. You can open it to any length you want. Just draw an arc in between the angles. Now here's the key. Once you have the intersection of the arc and the rays, go to that intersection point, draw an arc in the middle, keep your compass the same, and draw an arc here. And now you can see the intersection of the two arcs right there. That's where you want to use your straight edge now and connect from the vertex in between. All right, so that's constructing congruent angles inside, aka an angle bisector. All right, guys, that's a wrap on angles. Peace!